So this is lesson number 9.6 in intermediate algebra. We'll call it A because this seems to be a little bit long of a lesson here. And this is called equations with radicals. Alright, so one of the things that is true when you have an equation such as x plus 5 equals 10, we're trying to get the x by itself, and in order to do that, we subtract 5 from both sides. Alright, you know that. When we take 5x equals 10 and we try to get rid of the 5, it's multiplied, so to get rid of it, we divide. If something is divided and we want to get rid of the 6 to get x by itself, we multiply both sides. Okay, so we've got this thing that in order to get rid of a number, we do its opposite. Alright, we're going to continue with that as we go into this lesson 9.6. So one of the things that we know is that if we have the square root, if we have x equals the square root of 36, in order to get rid of that square root sign, we square both sides. So when we take the square, or square both sides, like I did here, let me put a 2 up here, then I get x squared equals 36. Notice what happened. When you square a radical, the radical and the exponent disappear and you're left with just a 36. Then if you want to get rid of the squared sign, you take the square root of both sides, and you're left again with just the x, because the 2 here cancels out the 2 and x here, so those go away, and that gives you the square root of 36, which is 6. So in order to undo a radical, you square both sides. In order to undo an exponent, you take the square root of both sides. And that's what we're going to be doing in this lesson. And I don't remember if you've already done it in the past, but if you have, then you're further along than I thought. So if you have a radical like that with a whole bunch of junk inside, okay, what we do is we first of all make sure the only thing on this side of the equal sign is a radical, and in this case it is. It's under 3x plus 4 is completely under the radical. To get rid of that radical, we square both sides. And when we square both sides, that gets rid of the 2 and the complete radical sign, and we have 3x plus 4 equals 5 squared, which is 25. And then we just solve that the regular way. We don't have a radical there, so we take away 4 from both sides, and then we divide by 3, and life is good. So the key thing when you solve these, so like if we did the 3x, we ended up with 3x equals 21, divide by 3, and we get x equals 7. Now we get x equals 7, but what we have to do, and this is a pain in the neck, I realize, but it has to be done when you're doing radicals like this, when you're squaring radicals, is you have to check your work. You have to put the number in here to see if it works, because sometimes it doesn't work. Square root of 25 equals 5. Square root of 25 is 5, so this one works. Alright, let's try one that doesn't work, just so you can see what happens here. I've got 4x minus 7. And that equals negative 3. Now if I square both sides, I get 4x minus 7 out of the radical, negative 3, the quantity squared, that gives me a 9. I add 7, and I get 4x equals 16. Divide by 4, divide by 4. I have done everything correctly. I have done nothing wrong. But when I take my radical and I put the 4 in there for my x, I get 16 minus 7 equals negative 3. Square root of 16 minus 7 is 9 equals negative 3. the square root of 9 is 3. Does not equal each other. So therefore, there is not an answer to this. There is not an answer that we can plug in here for x that's going to give us -3. Because notice, when we take the square root, let's move this out of the way, if we take the square root of anything, we always get a positive number, right? Because a number times itself is going to give us a positive. So therefore, because we said it was equal to -3 here, that gives us a clue that it may not work. We still have to do the work, but it may not work. And when it doesn't work, the answer that you get is called an extraneous root. Alright, the word root, get familiar with that. The word root basically just means the answer. If I want to find the root of such and such, and it's usually the answer x. It's usually x is the root. But it doesn't really matter what variable, but they usually use an x. But anyway, that's what an extraneous root is. It's one that works when you do the algebra, but when you plug it in, it does not work. Alright, so that's why you have to go and check your answers all the time, because if you give me an answer of 4 on a test, and it's an extraneous root, you're going to get it wrong because it's not the answer. Alright, so let's try example 3. 5x minus 1 plus 3 equals 7. Alright, one of the things that I had mentioned earlier in this video, we have to get the radical by itself. We can't solve this if there's a number over there, so we're going to subtract 3 from both sides. Okay? Then we can square both sides. Then we add 1. So x equals 17 over 5. That is our answer. Okay, and that is a pain in the neck. Sorry, because then you have to plug that in. Whoops, kind of made that a little bit long, didn't I? Because I need an equals 7 there. So 5 times 17 over 5, which it's nice that the denominator is that. This needs to be. Okay, so these will cancel. So we get the square root of 17 minus 1 plus 3 equals 7, or the square root of 16 plus 3 equals 7, or 4 plus 3 equals 7. And that works. I like that. So we're okay there. Alright, let's try the next example. The next example is 4, and they give us t plus 5, and they're saying that that's equal to square root of t plus 7. Okay, do the same thing. We square both sides. Now remember, when we square both sides here, we're not just squaring the 5 and getting 25 and the t and getting t squared. We're squaring the entire side. So that means we have to write it like that, which means we have to do FOIL. And that gives us, when we do FOIL, t squared plus, and you get to where you can do these in your head, because it's just double that, and then this number is the number squared. And that equals t plus 7, because that 2 makes my radical disappear. Now I'm going to bring everything to the same side. Sorry, that's a t, not an x. Okay, so t squared okay. Then we factor it into two binomials. Hopefully we can, or we're stuck using the quadratic formula or something like that. Okay. What times what is 18? Added together, going to give me 9. And that'll be a oops, a 6 and a 3. And they're both pluses. So therefore my answer is going to be what makes this 0 and what makes this other one 0. And those are my answers there. And now the hard part. We have to take both of these one at a time and plug them into the original equation. Alright, so let's move some stuff up. Let's move that down. Let's move this up. Alright, so there's the equation minus the blue. Can't really get rid of the blue, kind of stuck with it. I wish I could erase things, but after a while it kind of gets itself stuck and it won't let me erase. So I need to plug in -6 into this. So -6 plus 5 equals square root of -6 plus 7. So this is going to be -1 equals the square root of 1. What is the square root of 1? 1. Those are not equal. So -6 does not work. Now let's do the same thing with our -3. So we have -3 plus 5 equals the square root of -3 plus 7. So this gives me 2. Square root of 4. Square root of 4 is 2. So this one works. So what we find is -6 is extraneous. It does not work. And -3 does work. So -3 is the only solution that we have there. Alright, so I am going to pause this and go on to another video, 9.6b, for the rest of these examples, starting with example 5.